Good afternoon, everyone. Welcome, and thank you for joining our webinar today. So today, together with my colleague, David, who is the field application engineer, and myself, Luis, the sales side, we're going to talk about the AI and edge computing.
Good afternoon, everyone.
Okay, let's get started. In today's contents, I'm going to start with some market trends and the growing needs for local and edge intelligence. I'm also going to talk about the role of connected edge computing, how it works. Then David is going to show you or introduce how to build your edge AI solution. Then we'll present the InHand AI solutions together with some use cases. First, I want to show you some of the trends, a growing need for local intelligence. According to a market research, in the graph, you see the global edge computing market share or market size, actually. There is a projected growth from USD 55 billion US dollars in 2024 to 206 billion US dollars by the year of 2032, reflecting a compound annual growth rates over 18%. And if you look closer in the charts, you see nearly half of the market size come from hardware. And according to Gartner, more than 55% of data analyzed by deep neural networks will occur at the edge side by year 2025. In our observations, there are some general trends. The global rollout of 5G networks is accelerating the adoption of edge computing. 5G's high-speed, low-latency connectivity enables real-time data processing for applications such as autonomous vehicles, remote surgery, and immersive gaming. And there's also a growing trend of deploying AI and machine learning models at the edge to process data locally and to derive real-time insights. There are organizations, they are increasingly adopting a hybrid approach that combines edge computing with centralized cloud resources. This edge to cloud continuum enables them to leverage the benefits of both edge and cloud platforms, optimizing workload placement. And with data being processed and stored closer to the source at the edge, ensuring security becomes paramount. Edge security solutions are emerging to protect devices, data, and applications deployed at the edge from the cyber threats and also unauthorized access and data breaches. To our knowledge, there could be some typical industry sectors where local decision-making is needed more than others. For traffic and transportation, autonomous vehicles and traffic management systems could be a potential application. And for manufacturing, there can be predictive maintenance, smart factory automation, and more specifically, quality check with AI image detecting is very interesting. For smart cities, there can be urban planning, security, and infrastructure asset monitoring. So for InHand, we have deployed thousands of units already in projects like asset monitoring. And for healthcare, so real-time patient monitoring and telemedicine And remote surgery is requiring super low latency. So that's where the AI edge computing step in. So talking about latency, I want to list some of the key benefits of why intelligence at the edge is important and is a trend. So reduce the latency. Processing data closer to its source will minimize the time it takes to transmit data to centralized servers. And also, you have higher efficiency with bandwidth. So by processing data locally, edge computing reduces the amount of data transmitted over the network. So in simple words, the business owners will save more operational costs. And with edge computing, there will be enhanced data privacy and security. So edge computing allows sensitive data to be processed locally, reducing the risk of data breaches during transmission. And having a edge computing setup, you will have higher reliability for your system. So local data processing ensures that applications can continue to function even when connectivity is disrupted. So this will enhance the reliability of critical systems. This is very important to financial and healthcare applications. And with AI and edge computing, you will have better scalability and flexibility. Edge computing enables business owners, organizations to scale up their operations efficiently by deploying more or localized computing resources. This can be very flexible, and this can easily adjust and to meet with the changing of demands. So in this part, I want to talk more about the role of connected edge computing and how it works. This is a short definition, I want to say. So how edge computing works. Edge computing allows data from IoT devices to be analyzed at the edge of the network before being sent to a data center or the cloud. It combines the speed and autonomy of a local processing with the power, scale, and coordination from the cloud. I came up with this short diagram to show the steps of how it works. Starting with the data generation. So there could be devices like sensors, smartphones, cameras, and other IoT gadgets, which will continuously produce data from the field. And then next level, it will be edge devices. The edge devices are some specialized hardware, so such as gateways or edge computers. They collect the data near its source. These edge devices act as a local processing units. They sit between the data generating devices and the cloud. And the data being collected, they will be processed locally. So the edge devices perform some of the initial tasks like filtering, aggregation, or basic analytics. For instance, a traffic camera on the roadside, they might be able to analyze live footage, video footage, to detect congestions in a real time. After the edge site, it will be communication with the cloud. So after the data being processed, the essential data, ideally only the essential data like summaries, alerts, or key insights, will be transmitted to the cloud or a data center. But during the process, secure protocols like HTTPS, MQTT will be used to ensure the safe data transfer. And with the cloud integration, the cloud will step in, and for some more advanced tasks, which is beyond the edge scope. So, for example, advanced analytics, they will be running some complex algorithms like machine learning on historical data. And they can also perform some storage tasks, for example, to keep large data sets for quite a long time, to have a more in-depth analysis and or to make some compliances. The cloud should also manage edge devices remotely, such as to update the software or to upgrade the configurations as needed. In the feedback loop, the cloud analyzes data from multiple edge devices and sends back insights or instructions. For example, in a factory, the cloud might detect patterns across machines from different machines and adjust edge settings or parameters for better production efficiency. And last but not least, there is security. So data should be protected at every stage along the process. At the edge level, encryption prevents unauthorized access from local sites. And on the cloud level, there could be firewalls, VPNs, and secure APIs to safeguard transmitted data. Okay, now I'm going to hand over to David, who is going to talk more about the actual solutions.
Thank you. Hello, everyone. In this section, we will highlight how to build successful edge AI solutions. So first, we will look at some key metrics that make edge deployment effective. Then we'll run it through InHand's edge AI portfolio and give a brief overview. And then we'll share some real-world examples of how edge AI have already driven measurable outcomes in the industry. So some key metrics. So we'll first start off with TOPS. So TOPS is tera operations per second. So this is a measure of processing power for AI. For instance, the NVIDIA Jetson processor has an offering of up to 100 TOPS. If you use an AI for camera-based tasks, each camera typically would need around 5 TOPS. So for 10 cameras, you're looking at a solution around 50 TOPS. Latency, as mentioned earlier, is essential for real-time tasks like production of line quality control, autonomous vehicles. So latency should be under 50 milliseconds for real-world application, for effective performance, that is. So the other consideration is power efficiency. So this is really critical for battery-powered or remote applications where you need an efficient platform which will reduce energy consumption and extend operational time. So definitely for those applications where you may want a solution running off batteries. Size is another metric that you need to consider. So for applications where there is limited space, you want a unit which is compact and powerful. So you can use these things like camera housings or in robotics where, space is constraints. The other thing of consideration is interfaces. How you can connect to sensors, displays, control systems, ensuring seamless integration. So things like RS485, Ethernet, USB, cellular, Wi-Fi are all interfaces that you should consider in your solution. So together, these metrics help assess the real-world performance of edge AI solutions. So in this section, I'm going to talk about the AI framework. So there's 4 steps here in the life cycle of AI applications, from training through deployment and then management of those applications once they're in your network. So model training. So you need to train your AI models using popular solutions like TensorFlow or PyTorch. These are programming frameworks used to build and teach AI applications. After training, you will need to convert your model into formats such as Onyx. Onyx makes your model work more efficiently and across different platforms and tools. So it's very flexible and portable solution. Then you move into the phase of optimization and quantization as well. So after your model is trained, you need to make it a little bit faster, a little bit smaller, because you're going to be deploying it at your edge computers. You need to go through this optimization and potentially speeding it up as well. So you can use tools like TensorRT and Onyx Runtime, which will help do this automatically as well. Then you go into the stage of model deployment. So once your model is optimized, you want to send it down to your edge computers so it can start processing your camera feeds and monitoring your industrial applications out there. So you can use tools like Docker, which is a lightweight container, or go into Kubernetes for managing more containers to handle these deployments a lot more easier. These models are then connected to live data and you can start to process and make decisions in real time. So once you've deployed your solutions, you then need to remotely manage and update these. So it's very important that you have a platform which you can keep updated. So over the air updates is really important. And you need to make sure that you're updating for security fixes, bug fixes, and any additional features or improved applications that you want to push down to your processors. So that's a typical deployment. Then we have to now start matching your computing power to your applications. So for different industries require different levels of performance. So for example, we've got industrial automation. So tasks like detections, defect detections will probably need something like between 5 and 20 TOPS of processing power. Then you're moving up to more intelligent transportation. This is real-time tasks like license plate recognition. So you need around 10 to 100 TOPS depending on how many cameras and other requirements. Then for smart security examples, these tend to be slightly lighter tasks of facial recognition. Typically will need around 1 to 10 TOPS of processing capability. Then you're moving up into things like medical imaging. So these are precise tasks for monitoring X-rays, CT imaging, pathological detection. So typically here, you're going to be moving up to 20 to 50 TOPS. So we've got products which I'll talk about, like the InHand EC5550, which is a 100 TOPS unit. So this can support multiple applications simultaneously or handle very complex tasks as well. And of course, you have to consider other things like connectivity, power, size, and the interfaces required for your particular applications. So some more other considerations for building or choosing your AI platform. So things we mentioned earlier, latency. So low latency is critical for time-sensitive tasks. So you want a platform which provides low latency within processing, but also connectivity as well. Then you move into things like memory and storage. So you need to ensure you've got the correct RAM and storage for the data processing or capturing the video feeds locally for them to process those. Then you need to look at coding. Do you have the right frameworks? I mentioned earlier, like TensorRT and Python, which will help you speed up deployments of your applications. Then we're talking about things like ruggedness. So a lot of the applications we're seeing in industrial environments, so you need to choose robust hardware. These typically are fanless and work at very high and low operating temperatures as well. Then you move to connectivity. So this could be either wireless, it could be Wi-Fi, it could be 4G and 5G. So this is essential for applications that may be remote. So you need to make sure you've got connectivity so you can control and manage those remotely. Then security, this is really important. So you need to make sure you've got features like TPM and secure boot, very important for protection of your data both in motion and static as well. And then you also need security in your connectivity as well. So make sure that you've got the right platform to support that. Then you move into scalability. So this platform to support growth over time. You may be adding more devices or managing more workload as well. So that's very important to consider. And then going back to interfaces, ensuring your platform support the necessary input-output connections for your applications, but also for remote monitoring if you connect into a keyboard and mouse and a screen. So all these are very important considerations in building your platforms out. Now I'm going to introduce our comprehensive range of AI edge computers in InHand. So here we've got our devices on the lower tier of this diagram, and then we've got our cloud platform management platform device live. This is used for centralized management, over-the-air updates, diagnostics of your equipment in the field. And then we've got a wide range of products available, starting with the EC942. It's one of our entry-level edge computers. And then we'll move into the right. As we move up, we increase the TOPS performance. These are through with the EC954, the EC3320. These are all expansion modules for these products. So again, you can expand over time when you need more processing capability. Maybe you're moving from concept to real live deployments. Then we're moving up to our mid-range and high-end devices. These are NVIDIA sensor processors I've mentioned earlier. So you're talking about 40 TOPS and 100 TOPS. So these are really high processing capability for multi-stream video, for robotics, real-time vision, and autonomy. So these are really good processors. Just a few more details around our mid to high performance AI edge computers. So again, just to highlight a few things here, they're robust and fanless edge computers. Full cellular connectivity, so we'll offer 5G connectivity here as well as Wi-Fi and Bluetooth and GPS for location services as well. We're very much focused on security with secure boot and also TPM modules as well. So TPM modules are used for hardware-based security at the chip level and can be found in many modern computers and embedded devices. So again, we're very much focused on security because of the data you process in privacy and all those concerns as well. And then just move into our lightweight edge computers. So again, still with good performance. And again, just want to highlight a few things. These are also robust and fanless, so wide operating temperatures. We offer cellular connectivity across all our products. So again, 5G connectivity, Wi-Fi, Bluetooth, GPS. And again, just want to emphasize rich interfaces. So what are you going to be connecting these edge computers to? So using things like CAN bus, digital inputs, digital outputs, HMIs for local control panels. So again, very comprehensive products. And also, even at these lower lightweight edge computers, we're still focused on security with TPM modules and boots as well. Also, these devices are fully certified as well. We can provide further information around that. Okay, we've talked about hardware. Now we're talking about choosing the right operating system for your applications. We're not building your applications here, we're providing the operating system. So on the left-hand side, we've got pure Linux OS. This is a basic, clean Debian system with no extra applications. It's great for the customers who want full control and customization over their own deployments. You still get system updates for InHand for easy maintenance as well. And then we move into the center, which is the InHand EOS. This is a ready-to-use Debian-based operating system with pre-installed software for industrial IoT applications. This includes cellular and VPN network services, the device cloud management platform, device supervised agent for monitoring your devices, but also deploying your applications, and then full firewall configuration. So this is one of our most popular choices for quick deployment and with comprehensive support. And then on the right, we got the Opto build system. This is for advanced users or for OEMs. This option allows you to create your own custom operating system using the Opto project. InHand will then support the setup and pre-burning of customized operating systems at our factories. So when you receive these in your hands, they're ready to work out of the box. Okay, I mentioned device supervisor. So device supervisor is an agent, a plug and play field to cloud application. So the device supervisor agent, or DSA, simplifies your data collection, your cloud integration with zero code or low code approach, and it supports the data acquisition. So collecting data from various industrial devices. We support over 80 mainstream protocols here, so a feature-rich protocol support. Then we move into edge computer. So this is pre-processing your data locally, saving all your bandwidth that was mentioned earlier. And then we'll move into protocol conversion. We have more than 10 protocol conversions for easy integration into your systems. So we can work with you to find the best protocols for your application. And then we'll move to data cloud. So basically pushing your data securely to the cloud for analysis. So we support the full flow of data from data acquisition to monitoring to looking at the data in the cloud as well. So pretty much DSA reduces the complexity of deploying edge intelligence, moving data efficiently from field to the cloud seamlessly. Just a little bit more details on some of the 80 protocols. So we're talking things like Modbus, OPC, UA, BACnet as well. So we've got a rich protocol support. So all these protocols are to support the PLC systems, your sensors, your inverters, your meters out in the field as well. And we're compatible with major vendors like Siemens, Schneider, ABB, Rockwell, and Panasonic. So again, feature rich. Then highlighting smart data collection as well. We can customize polling cycles for each device. So you have data coming out of the device very quickly, or you may have data coming out, every 4 or 5 hours. So again, we can sort out the polling and collection data for that as well. So again, we can optimize your performance by reducing any unnecessary data load on your network as well. And all through the device supervisor, easy configuration. So importing, exporting device settings, using pre-built templates for faster deployment and setup as well. Finally, in the technology element, I want to just quickly talk about Device Management Cloud. The Device Live Management Cloud helps you remotely manage, monitor, and update your devices across any large deployments, including particularly Device Manager. That's pre-provisioning, configuration, and updating your devices remotely. Remote monitoring, getting real-time performance insight from your data and diagnostics from your devices in the field. And then we've got the edge compute management. So this is deploying your AI models, Python scripts, or your containerizations that you're pushing down to your devices as well. So again, you don't have to send engineers to site when you got a new update or new fixes to security. You can push this all through the Device Live Management Cloud platform. And you've also got remote access. So again, engineers can securely access your devices from anywhere, saving time and costs. So quickly looking at the time, I just want to introduce a couple of use cases. The first one is using a large language model at a service kiosk. So this application is using DeepSeek. So basically you're running DeepSeek on the EC5550, 40 billion code. So this is basically enabling local people to go up to the kiosk and ask questions. So the great thing about this is that you've got the real-time performance of 100 tops. So for real-time interaction, you've got intelligent search, fast, accurate. All your data's localized. So again, you're not waiting on the cloud, sending information down from the cloud. Robust security. Your devices, your data is secured on the device, so you've got no transit security concerns there. And it's very developer friendly as well. So you can connect multiple interface options. So again, you may want to extend the kiosk to multiple screens as well. So, a very good application there for a very enhanced edge computing device. Just one more case study I would like to highlight. This is a driver monitoring system. So again, it's using the EC5550 device. It's connected to an IP camera monitoring the person behind the wheel of a car. And then it's using YOLO, which is you only look once. So this model is a popular deep learning based object detection algorithm. So it can detect different classes of objects in real time from a video feed and make decisions on that feed as well. So the key features here, real-time processing at the edge. So it's all done locally, and you've got the enhanced security. So basically here, what you've got is a camera monitoring the individual. So if the individual suddenly picks up a can of water or a bottle of water and starts drinking, the system will detect that. And again, using things like the phone detection as well. And we've got a short video just to show this in a little bit more detail. Thank you for your time, everyone. Hope this video was interesting.
Okay. So before we wrap up, I would like to encourage you, if there are any questions, just feel free to use the Q&A feature to type your questions in the chat box. We will try to answer. Okay, so we'll talk about everything, almost everything. Lastly, there's a little introduction to InHand as a sub company, in case you are not familiar with us. So InHand has been active in the IoT communication solutions since 2001. We are shipping millions of products to over 60 countries around the world. And we are having wider global coverage with overall 400 employees. We have our headquarters in China, in Beijing. We have our overseas headquarters in the US, in Virginia. We have our sales offices also in Germany, in Düsseldorf, and also another facility in Toronto, in Canada. We are now having 3 manufacturing centers. The main one is near Shanghai in China. 2 additional ones in Bangkok, in Thailand, also in Toronto, in Canada. So over 3,000 pieces of products can be produced every day. And we have 9 production lines with high level of flexibility. So the lead time of the shipments is quite good. Okay, thank you again. Join us today. Don't hesitate to contact us by email. So we'll follow up on you.
Thank you, everyone. Have a lovely afternoon.